Hello everyone, this video is about chapter 5, lesson 3, inequalities in one triangle in geometry. So the point of this lesson is comparing the sides or angles of triangles using different methods. The first part of the lesson is about angle inequalities. What we are going to do by using exterior angle inequality theorem, we are going to compare the angles. So in this figure right here, we have an exterior angle, angle 1. This is an exterior angle because it's outside of the triangle. Is going to be greater than this interior angle or that interior angle. So it means measure of angle 1 is going to be greater than measure of angle A, and also it's going to be greater than measure of angle B. So that's all we are doing in the first part of the lesson. So here we have an example. It's asking for us to list the angles in the triangle that are less than measure of angle 1. So first we need to identify the angle 1. It's an exterior angle, and we are looking for angles that have smaller measures than this, which means they're going to be remote interior angles. So if you still remember exterior angle theorem from one of the previous lessons, it was like this. When we have a triangle with an exterior angle, let's say this is angle 1, that's angle A and B. So the measure of angle 1 was equal to the sum of measure of angle A plus measure of angle B. This is something we have already learned about exterior angle theorem. But this time we have inequalities. Greater, smaller, greater than or equal, smaller than or equal to. So angle 1 is going to be greater than either one of these. These are alternate remote interior angles, angle A or angle B. They are remote interiors. So we are going to do the same thing for this triangle, the one that we have. So angle 4 and angle 3 are remote interior angles according to angle 1. That's why both of them is going to be smaller than angle 1. So you can just put, it says list all angles. So the ones that are smaller than that is angle G or angle 4 and angle 3. So this would be the answer of the question, since they're smaller than, their measures are smaller than the exterior angle, which is angle 1. Okay, let's see these examples. It says use the figure at the right to determine which angle has the greatest measure. So we are going to be using the same theorem, exterior angle inequality theorem. So for this one we have three angles, angle 1 for the first one, angle 1, angle 3, and 4. So let's first locate the angle. 1 is here, angle 3 is here, and angle 4 is right here. So if you focus on this triangle right here, 3 and 4 is remote interior angles according to angle 1. Angle 1 is the exterior angle. So if that's the exterior angle, since again this is the exterior angle, that's going to be the greatest one. So it says which one is the greatest measure. So angle 1 is going to be the greatest measure because that one is the exterior angle. The others are two remote interior angles according to angle 1 because they are inside the triangle, these two, according to angle 1. Now let's move on to the next one, angle 4, 8, and 9. So first we are going to locate them. If one of them is the exterior angle according to the other two, then that's going to be the greatest measure. So let's look at the angles 4, 8, and 9. 4 is here, 8 is here, and 9 is here. So these two are the remote interior angles of this triangle according to angle 4. So angle 4 is the exterior angle and the other two are remote interiors. So the one that is outside according to the other two, here's the first one, the second, and the third. Angle 4 is the exterior. That's why that's going to be the greatest angle of these three. The next one, angle 2, 3, and 7. Let's just focus on them. 2, 3, and 7. So if you just concentrate on these three angles, 2 and 3 are remote interiors, and angle 7 is the exterior angle according to this triangle and the other two angles. So 2 and 3 are remote interiors, 7 is the exterior. That's why angle 7 is going to be the greatest one. Next one, we have again three angles, 7, 8, and 10. The one that is exterior angle is going to be the greatest one. 7 is right here, 8 is here, and 10 is right there. So when we just focus on these three angles, 7, 8, and 10, the one that is outside is angle 10. The others are inside the triangle, 8 and 7. So they are remote interiors according to angle 10. Since angle 10 is the exterior, that is the greatest angle of these three. So let's move on to the next question. Use the exterior angle inequality theorem. That means just locate the exterior angle that's going to be the greatest one. To list all angles that satisfy the stated condition, measures are less than angle 1. So if you are looking for angles that are less than this should be the exterior angle. So let's just focus on angle 1. Angle 1 is right here, here, and that is the exterior angle of this triangle. So when we just look at this triangle, we need to identify the remote interior. So right now, in this triangle, we have three interior angles, these three. But this is not remote because it's right by the angle, right by angle 1. But these three, they are the remote interior angles. So that's why they are going to be less than angle 1. These two are going to be less than angle 1. Measure of angle 3 and measure of angle 4. Now, also, there's another exterior angles of these three. If you just look at angle 3 right here, that's an exterior angle too, which means there are other angles that is less than angle 3. So if we have other angles less than angle 3, they will definitely be less than angle 1 because these two are already less than angle 1. So angle 1 is greater than all of this. It's greater than angle 3, it is greater than angle 4. So if you have angles that are less than angle 3, they are going to be less than angle 1 as well. So let's just focus on that part then. If angle 3 is an exterior angle, if this is an exterior angle of any of the triangles, then the remote interiors are going to be smaller. So let's just look at this triangle right here. So that corner, it's not named, so we are just going to skip that one. But this one is also, angle 5 is also remote interior angle according to angle 3. That means angle 5 is smaller than 3. So if it is smaller, it is smaller than 1 too. Next, we are going to do the same thing for angle 5. If this is an if this is an exterior angle of any triangle, like this one here, then there are going to be angles that are less than angle 5, such as angle 7 here and angle 8. Because if we just look at these three angles, 5, 7, and 8, 5 is outside of the triangle, 5 is outside of this triangle, that's why it's the exterior angle, but 7 and 8 are remote interiors. That's why they are less than angle 5. So if they are less than angle 5, they are definitely less than angle 3, and they are definitely less than angle 1. So these are all less than angle 1. So the next one says measures that are less than angle 3. So all of these angles are less than angle 3 because we just figured that out. Angle 3 is the exterior angle, so it's greater than these two, and that angle is greater than these two. So we can just put the same ones, angle 5, angle 7, and angle 8. Okay, here is the second part of the lesson, angle-side relationships. In this part of the lesson, in some of the examples, the sides are going to be given like this one, and then we are going to compare the angles. Or the angles are going to be given, and we are going to compare the sides. So when we do this, we will keep this in mind. If we have a side given, that side is going to be related to the angle opposite this side. So, or if we have this angle right here, that angle is going to be related to the side opposite this angle. So for instance, AC and angle B are related, angle A and side CB are related, side AB and angle C are related. For this one right here, side SR, which is 6, is related to the angle. This side, 7 centimeters, is related to angle R, and then angle S is related to side RT, which is 9 centimeters. They're not equal to each other, but the longer the side, the greater the angle. Or you can think the greater the angle, the longer the side across from it. So let's look at the first example here. It says list the angles. We are going to make a list of the angles S, R, and T in order from smallest to largest measure. So the smallest measure, the smallest angle is related to the shortest side. So here's the shortest side. So once we get the shortest side, the one opposite the side is going to be the smallest angle, shortest angle. So angle T is going to be the smallest measure. Next side, greater than 6, but it's not going to be the longest side. So 7 is the next one. So across from that, we have angle R here. So that's the next one. Angle R is going to be greater than angle T. And the last one, the longest side is RT. The one across from the side is angle S. So angle S is going to be the greatest angle measure. Example 2. So it says list the sides. So the sides again about the angles opposite from each side, from shortest to longest. So the smallest angle is here, 20. So opposite this angle, the side that we have is CB. So that's going to be the shortest side. Next, just look at the angle that is greater than 20. So greater than 20 is 35 degrees. So this is going to be the one opposite this angle is going to be the next side, which is AB. So this side is going to be the next one. So to get the longest side, we need to look at the greatest angle right here, 125, and opposite this angle, the side that we have is AC. That's going to be the longest one. And here are the last two questions that we will deal with. We are going to compare these two angles. First, let's locate them. So I'm going to say this angle is going to be labeled with green, and that angle is going to be labeled with red. So let's first locate angle QRW. Angle QRW is the corner that I am surrounding right now, which is right here. So I'm going to label that with green. And the next one, angle RWQ, is going to be RWQ is the corner that I am surrounding, which is right here. So let's label that one too. Now, you're going to compare them. And here's the thing, the sides, the opposite sides are related to the angles. So across from red angle, this is what we have. Across from the green one, the side that we have is 45. So since 47 is greater than 45, this angle, the one that we labeled with red, is going to be greater than the one that is across from 45. So we can say that measure of angle QRW is going to be less than measure of angle RWQ. If you use different colors to label the angles, it might be easier for you to determine which one is greater or smaller. So the last example is about comparing the size. Angles are given. So here's what I'm going to do first. Since I'm going to compare some of these sides, I want to make sure that I have all of these angles on the figure. So before I start even solving the questions, I want to label this angles. So this angle right here, since we have a triangle, all of these angles, this one, the one that is unknown, 120 degrees and 32 degrees, must be equal to 180. So what I do to get that angle at the top is adding the ones that I know, which is 152 degrees, and subtracting them from 180 degrees. So I get 28 degrees for this angle. Now let's move on to this triangle in the middle right here. So I'm gonna start with this angle because I know I can figure that one out. I don't know how to figure this angle out before this. So here's how we can find this part of angle E. Angle DEG is gonna be equal to, since we have a linear pair right here, these two angles, that one and 113 degrees, are making up a line. That means their measures are 180 degrees. So by subtracting 113 from 180 degrees, I can figure out the other half of the angle. So it's going to be 67 degrees. So that angle right here would be 67 degrees. Now I have 48 degrees, 67 degrees, and I'm missing this one. That means if I add these together and subtract them from 180 degrees, I can figure out the last one, the one in the bottom. So let's do that one. 48 plus 67, which is equal to 115. Sorry, it's 115. And then if we subtract that from 180, we get 65 degrees, which is right here, 65 degrees. Now we can easily compare each side by looking at the angles that are across from them. So now let's compare these ones, DH and GH. Side DH is right here, and across from this side, the angle that I have is 32 degrees. So I'm just going to put 32 degrees here just to be able to compare them. This is not the measure of the side, it's the measure of the angle opposite this side, but they are kind of related. So let's move on to the side GH. It's right here, and the side across from this is the one at the top right here, 28 degrees. I think right now it is easy to compare them. So DH, the length of DH is going to be greater than the length of GH. Let's move on to the next one. I'm going to label DE with orange and DG with purple. So right here we have side DE, and across from this side, the angle that we have is 65 degrees. And across from side DG, first let's find the side right here, and across from this we have that angle. It seems like I forgot to put its measure. So no, I didn't forget it, sorry. The angle is right here, 67 degrees. Now I can easily compare these two. Since 67 is greater than 65, I can say that the length of DE is gonna be less than the length of DG. That's all for this lesson, guys. If you have any question, comment below, and I will see you in another lesson.